Hi, thanks for joining us. I've managed to rope one of my engineers in as well, so there's actually two of us doing this now. Hopefully it'll make it a bit more interesting for you. So yeah, thanks for joining us tonight. A bit of an introduction to who we are. So I'm Matt Levitt. I'm the head of platform engineering at Peer Media Group. I've worked in IT for just over 20 years now, doing a wide variety of roles from sort of technical support, DevOps, and my latest platform engineering.
I'm Danny. I guess I'll shout, there's only one microphone. About 15 years with PA Media, worked my way through tech support, back through the days, through Windows, that type of scenario, into DevOps, SRE, and now I'm a platform engineer.
So a bit of an overview of our company. If you've never heard of PA Media Group before, the chances are you'll have either used or seen some of our content, either editorial news or images, betting information. We're built up of a variety of companies, so it's smaller businesses all under the PA Media Group header. There's been a few acquisitions lately, and we've just had a rebrand for our sports betting and data business, which is under Podium, so that covers the racing as well. We've got StreamAMG, which is a video sports streaming, and Alamy, who's mainly deals with images, so you probably see images in news or documentaries and things. They always pop up in there. So we just wanted to start with a bit of an overview of what our platform engineering journey has been so far. It mainly started out in 2022. This was due to our overall AWS cloud usage growing. As the business acquired more companies, we came under one AWS organization and it grew. We started move to more centralized load balancing through F5, and the business development squads that we use, they started to make more use of AWS containerized services. So the team initially started out with 2 engineers. We've got one of them here tonight. And we kind of created a bit of a mission and vision statement for how we wanted our platform engineering to go, which was to provide stable, scalable, efficient and secure technology platforms with clear guardrails to enable business value delivery and innovation. Then in 2023, the team grew to 6 engineers, and we carried out a major AWS re-architecture project. Again, this was because the business was growing, we was acquiring more companies. We wanted to do some work to centralize networking and ingress, improve security, put processes in place around guard duty, cost optimizations, cost alerting, centralize the management of accounts. We use Control Tower for that, and put in full business account separation so that each area of the business is treated as an independent business, and if there was an incident within one specific area, it's not going to impact another one. We then also started working on our Kubernetes, so it was investigations, understanding the marketplace, what was out there, and putting a case forward for budget. We managed to secure the budget, and then in 2024, we started working with Rancher. We did the design, POC testing, and then the start of the rollout, which we're going to go through now. So for our Kubernetes assessment, we created a mission statement, which was we wanted to deliver a standardized, centrally managed hybrid platform, which can scale alongside business demand and be rolled out to other cloud providers and onboard other businesses that we acquired if needed. The project requirements was for it to initially be rolled out across the kind of core PA areas and StreamAMG, but to allow for other businesses to be onboarded if we acquired any larger ones in the future. We wanted for containers to be deployed both on-premise and within AWS, so we do have an on-premise, it's a Nutanix platform, and we use the AWS services. We needed to have that functionality to scale out to other cloud providers if needed in the future, and to allow product development squads to deploy their services, and it needed to be scalable, resilient and secure. And one of the other key requirements that we had as well was for whatever solution we put in place needed to have enterprise support, because this was going to be the core of our business going forward for the platform technology. So for our Kubernetes assessment, we created a vendor review matrix. This was broken down into 7 categories, which was security, scalability, management, availability, infrastructure, monitoring, reporting, and then we kind of created other miscellaneous section. Within these, we broke each category down, and we kind of used Moscow style with the must-have, should-have, good-to-have, and nice-to-have, each one getting scored. We worked then with the partners to go through that, to score it, and then pricing and cost models was also reviewed because the vendors offered different models for licensing. Some were saying you got one license was X amount of cores, where others would be just one node was one license. So this was another consideration at this point. So after reviewing all the data, we discussed it as a team and we made the decision to go with Rancher. The reasons we did this were, it's quite difficult this being behind. It met all our requirements and it scored joint highest with the vendor comparison matrix. We felt that having the additional security application and new vector there, it was a really good added bonus for us, you know, that extra layer of security and being able to get really defined security management on the platform to make it more secure. The feedback from the team was we had a great engagement with the SUSE Rancher team and it really felt like we could build a partnership with them. And also it's backed by the large open source community as well, which was another good benefit. And the license model was most flexible for us with that on-demand scalability. We're not limited on the size of each node, so we can choose to scale horizontal or vertical, and we'd only need additional budget if we was adding additional nodes in. So this is a bit of an overview of our architecture design for the platform. We went back and forth a few times with different options. We eventually settled on this one after we had a production readiness assessment where we worked with one of the Rancher architects, went through our design, how we was planning on doing it, and it was mainly around the control part. I don't know how well that's showing for you there, but originally we was looking, because the business areas are all individual in their AWS accounts, we was looking at having controllers within each AWS account to manage each business area's cluster, but that was quite costly. So we settled on this design. I'll let Danny go through it a bit more in a minute, but using EKS for the controller, we have the Rancher Prime servers for each production, staging and dev in a platform AWS account. So they're managed by the platform team. And then each business area will have their controller clusters and their worker nodes. So I'll hand over to Danny.
Thank you, Matt. So what you see on the screen at the minute is probably about 8, 9, 10 iterations in what we chose. So we decided to finally, as Matt says, land on what we've got there. Basically, we build EKS clusters and we now import them into Rancher. It makes our life a lot easier. We can make it more simplistic for the account integrations. Business areas live in their own accounts. The security is more robust because they're actually ring-fenced between themselves. Nothing can break out to other account areas. For an example as well, unexpected outages on one cluster, it will only affect one area of PA. If content goes, racing is not affected. Everything's segregated out. It also allows us to work around a different business change window scenario. For example, content might have a window of 2 till 4 a.m. Racing can break down into middle of the night. It allows us to keep things a bit more simplistic for our management. Also, cost. We no longer have 3 controllers per account area. EKS just takes over and it's a much simpler cost rather than your EC2 instances in your ranches. So, now please bear with me. Basically, we have a platform. All great. Everyone loves a platform, but in all honesty, it's all up to the developers to actually start to use it. So basically, we have to get them on the platform. And the simplest way to do that is to keep it simple. So we broke it down into 2 objectives. The first objective is to make it simple, as always. Make the deployment simple so the development squads can focus on development. None of the developers really cared at PA. They just want to deploy something. It just wants to run. Don't care what it's on, just want to run it. Objective 2, make the migration from AWS ECS as simple as possible. At PA, we use Terraform. and our main platform at the moment for containerization is ECS. So it's getting them off there onto Rancher. So the solution is to create a Terraform module and build a PA Media Group specific standardized Helm chart. So we defined a Terraform module that allows us to control any standards which match the deployment patterns. For example, our module will create the namespaces, it'll generate the F5 integration, any labeling that we want in it. We built the module so all the resources are from the Terraform provider. All the product developer must do is create or update a stack by calling the module, get some values, get some YAML. It also allows them to run in parallel. They can drop the module into the current infrastructure stacks, deploy it over to Rancher while still running ECS. We now have a nice canary deployment for them to test. So what's it look like? That. Basically, we boiled it down to the simplest thing we could, the smallest module that does all the heavy lifting for them. And literally, they put that in and it can deploy what they've got. Task 2, Helm chart creation. So the trickier part is the Helm charts. What approach is the simplest for the product development teams? Understand it, we carried out a small discovery phase which highlighted we required auto-scaling, which is your basics on metrics and HPA, IRSA, IAM roles for service accounts, secrets and environmental secrets using the external secrets operator, config mapping, secret config mapping, all again external secrets, define resource limits, integrate container security, building the F5 integration and the storage. Once it was complete, we had to toddle off and build a Helm chart. So basically, we toddled off and built a Helm chart. We then publish it into Rancher, available for all the developers to use, different versions, etc. and such, easy. So what's it do? Well, it deploys a container, but what else? We define secrets. So the Helm chart can actually define the creation of the secrets using an external secret operator. It'll either create your Kubernetes secrets or manage your config map or an environmental variable. All of this is pulled from AWS Secret Manager, or as you know, external operator can use other secrets as we had. So basically, all they do is define the cluster store that they need in the name of the secrets. They'll go off and generate the rest. Security. This is probably the only part the developers need to think about, and the main thing is to actually build the container to actually run as non-root users and actual users. So they have to think a bit about that, but meh. IRSA. So basically, we incorporate OIDC, which can annotate the service accounts. It defines what the pod can access in AWS, but we just use a Terraform module, which is just out of the box, which creates a service account as the required annotations to the role. Ingress. F5 ingress is quite heavy, so we use the big IP ingress controllers, the CIS stuff. We built the Helm chart to do all the heavy lifting in the back end. All the developer has to think about is simplicity. Host name, service names, namespaces, just nice and simple. Scaling. We do make them think quite a bit about scaling. Developers have a habit of saying, my pod wants everything that you've got. So we're utilising new vector emission controls to define limits based on what the pods. So they can't go in along and say, I want everything, I want 5 gig. We set them by default as quite low. That way the developer has to go think. So they have to think about what they want it to run as, how they want to scale it. Basically, it's a little bit of thought. Very rare that they do. So basically, got a nice little demo here utilising Explore, which is our new product at PA, just to show it all working together, how easy it is for them to move and such. And it is a little video that tries to show you through it. It's a bit of a quiet spell. So as you can see, nothing's working. It is quite poor quality, apologies. So nothing's working, nothing's there. As you can see, I will just try and whittle on through this. So here we are with Terraform, with the module, and that is really poor quality. So there's the module that's in the Terraform stack. We pass it the YAML. It is a bit bulked out, just because I like YAML. It has the values that you want in, the host names, everything else that we've just gone through. We sit and wait. We run an apply. It does things that you can't see. Sorry. It did look better when I ran through this earlier. It's a lot clearer, you've got to admit. So anyway, there we go. It's starting to apply now, and you'll see things starting to come into ranch here. Not that you can. That is quite poor. So, you see the deployment and the workload starting to build up. A little pod starts to drop in. 2 pods. Starts to run, pods become healthy. And then wait a bit longer. It's not that long. There we go. Everything's applied in, less than a minute. They have a working platform. So in there we've created the namespace with the resources that go with it. You can see the application, so they can see quite easily if there's any upgrades to the Helm charts, what's required and what's part of that. The secrets. And the actual application. All within less than a minute. Quite happy. The next step is destroy. I'm just going to move it on from that because it is just a destruction. But it's the same principle, really. It falls over just as quick. So, what's next for us? At the moment, deployments are not quite fully end-to-end as we would like. We've still got a requirement for the engineering side to manage F5 DNS integration. We're handling this on the next project that will allow the developers to do that full-blown end-to-end stack without us, which is quite nice. So we made it all modularized and standardized. It captures about 99% of the requirements for PA. There's always an edge case that we've not captured. But as we standardize further, the changes that need to be made can be done in a controlled fashion without disruption to products that are already using the platform. So basically, we've tried as best to do everything possible to make it as simple as possible for a developer to move over to the platform with not really caring about putting that much effort into it. We also need to work a bit closer with NewVector. Basically, NewVector on an IAC side of things is still pretty immature. So we want to try and make that a bit nicer. So actually we can still keep the control and governance that we're actually managing on a manual basis and actually try and bring it a bit nicer towards us, make our life a bit easier. There's always improvements we can make. We're still immature, but we're trying to mature the platform. But hopefully the way we built it, that these changes that we need to make can be nice, small, incremental, and only affect certain areas where needs be. So, back to Matt.
Yeah, so for us, for this year and going forward, the big thing for us is platforms as a product. We want to treat our platform engineering team as a product engineering team, delivering products for our customers, which are the internal developer teams, and really start to build it. So to help us do this, we're going to be growing the team, so we're adding some key roles to it. Going to be looking at getting a DevX and product owner, someone who can really work between the platform engineering team and the product engineering team as a gateway to bring their features and requirements in. You know, we want to be building platforms for them that they want to use and making sure that what we're delivering is what they need and is meeting their requirements. We're also looking at data analytics. really start looking at capacity planning on the platforms, as well as AWS costs, and being able to pull detailed reports to there to help business stakeholders to understand and manage their costs, and also a platform architect as well, which is more vital as we move towards our kind of long-term vision, which is to build this internal developer platform, and which Rancher is going to be a key piece of, and that's going to be the big things for us on our journey next. And then obviously we're going to be rolling Rancher out across the other areas for the businesses within AWS, and then looking at on-premise deployments as well. So that's it from us. Thanks for joining us. Happy to take any questions now, if anyone has any. No questions.
Lovely.
I've got a question. In the absence of anyone else jumping in, just curious, you mentioned making the...
You need a microphone.
You mentioned making it easier for your developers to move across from the previous platform. How's that been? I mean, generally, it's kind of like, did you need a shove from somewhere, or were they happy to jump on board?
I will leave that to the boss.
Thanks.
Basically, my aspect, you need a good manager with a good vision in order to actually help the other areas to get on board with what you need. But that's where boss comes into play quite nicely. Politics.
I think the big thing is, and this is where it kind of goes into where we're moving this year with having that DevX product owner. So we need to be able to sell it to them to show the benefits.
Yep.
And then that's got to be sold back to the business areas, because obviously it's going to take development of time away from features. So you've got to show where the value is in that. So by having somebody that's working more closely with the development squads and being able to show them the benefits, and then kind of using a marketing strategy of focus on one area and then get them on board, get their architects on board, get them to sell it to the other architects, and start to drive hype around it of we're saving this much time, or it's helping us in these ways. That's kind of the direction that we're going in.
Yeah, cool, thank you.
So you mentioned moving to do some stuff on premise as well. What are you looking at with that on premise platform? Have you got anything at the moment, or
we
plans?
So at the minute for our on premise infrastructure, we have Nutanix with VMware running on top. So the plan is to look at putting Rancher onto that, and then potentially further down the line maybe putting Rancher onto Nutanix. But at the minute there's a requirement for some of our legacy services that need VMware to run on. So we've got some Solaris and things like that which can't run on Nutanix, I think. Other people have got a similar story. But yeah, it would be to kind of look at deploying Rancher onto the Nutanix or VMware platform and kind of building the business clusters on there. Because a lot of our legacy apps are kind of microservices, so they're ideal candidates to be able to containerize and shift across.
Cool, thank you. And then also, are you using for the AWS stuff, are you using the Rancher 2 Terraform provider stuff?
Yes.
Maybe, I think
The
you might have
module's
mentioned
built
that.
on the,
Yeah,
on
you-
the Rancher providers, yeah.
Cool, thank you.
Thank you. You mentioned you moved from ECS to EKS. I'm curious to know if you've saved money through that, because EC2, Fargate to EKS, is there a bloat there? And how do you track, like on ECS, you can track the cost pretty easily. Moving to EKS, how do you track costs for individual things?
More of a budgetary question there.
I don't know.
I will add that the ECS stuff is quite wasteful. The current pathway that our developers are using is a minimum of 2 EC2s. Thank you. 2 EC2s with an ALB in front of it. So we circa that around $30 per service. It's smallest level. You start migrating to the fixed costs with the RIs, and everything else that's built in. That's where you start to see the costs come down. So you have your initial cost up there while you build your clusters out. But then as they start to shift, your ALBs start to drop off, quite expensive to move into the F5 ingresses, but you're also losing your EC2 instances and everything that goes with it, and the manageability as well. Your ECS is quite a heavy load. We're maintaining that with your AMI updates and everything that goes with it in security. But there's a budget man here that actually tracks costs as we go through the lines.
Yeah, it is just that kind of migration piece and being able to say, you know, we estimate we can get X amount of ECS instances onto. Kind of, I when I spoke to my manager about it, I kind of looked at it as the old days where he was moving from physical tin to virtualization and being able to say, right, if we build these 2 Rancher hosts running on these EC2 instances, we estimate we'll get X amount of ECS services, and then being able to factor of how much cheaper it would be that way.
No, I appreciate that. The main thing, like I'm going through that, sorry, so that's why I keep mentioning it. Moving to EKS, I mean, like if you're running stuff in AWS, EC2 machines, Fargate, ECS, anything, you can really use the tags and billing reports and all that to really dig down and see that's what's costing stuff, or that's what that feature, that particular deployment costs that much. On EKS, you can still do that using open source tools and stuff, but it just keeps adding bloat on top. Like I have to run another thing for KubeCost or OpenCost or something to really get stuff out. I'm sure you don't have that problem. I'm just curious if you cared about individual cost of deployments, and if you found a way to easily track that using AWS EKS.
Do you want me to go?
Yeah.
For our costs, it's at the minute we're not providing detailed service costs. It's more of overall business costs. So because we're running individual AWS accounts with individual Rancher nodes on EC2 within that account, we're able to say, you know, this business area is costing this much. But we have been looking at kind of costings for the future for being able to say this service is costing X amount. But I think that's going to be done more of a portion of a host, because it's kind of, we're using full hosts for the containers to run, or the pods to run.
I will say it's where the module comes in handy. We can modify the module to enforce specific labels. So you can actually start passing your labels through as a variable, which can start tagging, you know, your namespace, for example. We define that each business product has its own namespace, so you can drill into the namespace with KubeCost, like you say, which Mike's been looking at. With KubeCost to actually drill into if they want an individual costing. But as far as our AWS platform, we do already do the tagging around billing code service, you know, so we can have that metric within AWS, but it allows us to take it into Rancher as well.
Yeah, cheers. Thank you.
And do you have a question?
Yeah, I had that. So when you are managing, so how are you managing your state files when you are modularizing everything by a single module?
Yeah, so state is managed by the AWS backend. We write them to S3 with DynamoDB locks. Although recently Terraform has released an update to the provider where you don't actually have to do that anymore, but a state is a centralized S3 bucket, encrypted, and we use the DynamoDB just to lock them at the moment.
Hi, I just wanted to ask about, you put all your features that you've implemented on there, your journey between yourselves and the application teams, and kind of like what falls into the hands of the application teams versus what you guys have implemented.
So our developers have always kind of dealt with their own little Terraform stack, the infrastructure side. So for example, one product might have the DynamoDB in with an S3 bucket on their ECS service. So they kind of build it all into that singular and then manage the task definitions that run the pods. So they would still maintain their infrastructure to a certain degree, which is where NewVector also steps in for the security layers. So they've always done that. So basically, they will just carry on doing that. They will drop the module in, and it will just integrate with what they've already got. So we just try and leave it in their hands to deal with what they need to deal with, rather than trying to break it out that I want a container. But then this other team has to build my DynamoDB, and then someone else has to go do an S3 bucket. The easier you make it for them, the quicker that return on investment is. It can just shove something through the door. So long as everything is peer reviewed, then you know the security is there. If it's all done correctly, you have to have a layer of trust with the people that you're doing. Everyone talks about the zero trust, but sometimes you need to trust them to do what they need to do in order to progress. They do stupid things happen. But if you've got your layers there to stop it, we use other tools at PA. We use the Sneak, we use NewVector, etc., etc. So we do have layers in there to stop stupid things, penetration, protection, investigations, and all that malarkey. It's all there. So yeah, literally, we leave it in the hands of them. Obviously, they work with the DevOps. They just sort it out themselves. We just keep an eye on them.